Let's begin with a simple and relatable example to understand the concept and usefulness of matrices. Imagine a table showing five people: John, Amy, Alex, Bob, and Selena. Each person owns shares in three companies: Apple, Nvidia, and Microsoft. The table has three columns labeled Apple, Nvidia, and Microsoft, with each row showing the number of shares each person owns. For example, John owns 12 shares of Apple, 23 shares of Nvidia, and 8 shares of Microsoft. Similarly, each person had their own row in the table showing their shareholdings for these companies. Now, let's consider the stock prices for these companies. At the time this video was created, Apple shares were priced at $237, Nvidia at $135, and Microsoft at $419, rounded to the nearest dollar. To calculate the total value of John's stocks, we multiply 12 by 237 plus 23 by 135 plus 8 by 419. This gives us the total dollar value of the stocks John owns. We can repeat this process for Amy, Alex, Bob, and Selena using their respective rows in the table. Here, here is where this concept of matrices and vectors comes into play. The table of shareholdings can be represented as a matrix, where each row corresponds to a person and each column corresponds to a company. The stock prices can be represented as a vector. When we multiply the price vector by the matrix, we calculate the total stock value for each person. This result is another vector, representing the total values for John, Amy, Alex, Bob, and Selena. Mathematically, this operation is represented as x equals A multiplied by B. Here, A is the matrix of shareholdings, B is the vector of stock prices, and x is the resulting vector of total stock values. Now, let's formally define a matrix. A matrix is a rectangular array of numbers, symbols, or expressions arranged in rows and columns. Each number in the matrix is called an element, and its position in the matrix is specified by a pair of numbers, one for the row and one for the column. For instance, the element in the second row and first column is identified as the element at position 2, 1. The size or dimensions of a matrix are determined by its number of rows and columns. A matrix with 3 rows and 4 columns is called a 3 by 4 matrix. If the number of rows equals the number of columns, the matrix is called a square matrix. Matrices can also have special types, such as diagonal matrices and identity matrices, which we will explore later. Matrices are essential tools in linear algebra because they allow us to organize and compute data efficiently. They are widely used in data science, computer graphics, physics, machine learning, and many other fields. Understanding how matrices work and learning to perform operations with them are fundamental skills that enable you to solve complex problems and gain deeper insight into data.